in fact, because you know that you need at least 2 or 3, because one, it does, for example, you have 2 attacks that come from China. Well, almost all the attacks come from either from China or from US. So by using this, you can say things like most of the feature must be high in order to link to events to the same root cause. Okay, so just going to show you an example of application of that approach, and then I will give the word to Andy. So we have applied this approach to different types of data sets, and among others, we have applied that to rogue AV software. And we have published then the results in the Symantec report on rogue security software in October last year. So, what is a rogue AV software? Well, I think I don't have to repeat that because now it's well known. It's a kind of misleading application. Some people call that also a scareware. It propagates through different techniques, mostly techniques that aim to lure users into installing some software. And the purpose is, of course, to make money, because when it's kind of malware that when you install it, it will ask you money to have the full version, but in fact it is just a fake software, so it does almost nothing. So you have here some screenshots of a rogue AV software, such as Malware Protector or Antivirus XP 2008. And we see more and more of samples of that kind of threats. So we wanted to apply our approach, triage, to this kind of data. So what did we look at? Well, we selected about 6,500 domain names that somehow looked suspicious. And then in those domains, they were pointing to roughly 4,300 different IPs. And you see that in those IPs, some of them were clearly hosting only rogue AV software, whereas only 110 were hosting both rogue AV and normal domains, or some other threats. Some other threats. And finally, what is really interesting is that you have also roughly 1,500 domains that were hosting both rogue AV software but also normal websites, normal domains. So this is not easy then to figure out which rogue AV domains might be due to the same group of people. So yeah, so just one more slide on the generation of the data. So you see here the domains that we have taken from SafeWeb or from malware domain list, malware URL, host file, and then what we did, we have added other data. So we wanted to know, for example, to get information about where the domain is hosted, so DNS, and we used RobTech to do that. Then we wanted to know the availability of the servers. Then we wanted to know who is the owner of the domain, or who has created those domains. And lastly, we have taken advantage of SafeWeb and malware domain list to include in the analysis information about threats. So which threats are present on each domain. And this is our feature set. And then we apply the approach that I have shown. So we applied the MCDA, a multi-criteria clustering, on this data set. And what we find out, so the aim is, of course, to analyze the campaigns. So you see all the point here is to find the root cause. So to group all those domains, all the domains that might be due to the same campaign, so to the same group of people. And also, what are the connections between the web servers, where we find those RogueAV software, the RogueAV domains, and the information that we have collected, like the registrants, the creation date, etc. So these are our findings. Roughly 4,000 domains could be grouped into only 39 campaigns. And we find even one campaign that is made of roughly 1,500 domains. So it means that all those domains were created by the same group of people, the same modus operandi. Most campaigns are short-lived, a few days or a few weeks, but we found 2 large-scale campaigns that have lasted for months, and even one for more than 8 months. Then, as you will see in the next picture, we have found out that the rogue domains are created in a bulk fashion, clearly. And the same campaign is usually split between different internet service providers. Now, just to give you an idea of what we get with the approach is you get a multidimensional graph where you can plot all the features that you look at and all the data. This is one example of a RogueAV campaign, which involved, in fact, 750 domains, RogueAV domains, that might be due, apparently, to the same group of people, because all the domains, you see that all the domains are linked by a certain number of features, but not always the same features. Some domains are linked by, so just to give you the legend, so in blue you have the RogueAV domains, so the name of the domains. Then in yellow you have the IP address in /1024 of the web servers, and in red you have the email address of the person who has created the domain, registrant email. And you see, for example, that all those domains were created by the same persons, apparently, on the same date. Then you have bubbles, in fact, like a bubble here, created on the same day and due to the same person. But you have different networks, so it means that they try to split, to host all the domains on at least 2 different IPs, just in case one ISP tries to take down a whole set of RogueAV domains. So you have, and sorry, here you have the creation date, of course, here. So it lasted 8 months, but only on 2 or 3 days you see that they created a large amount of those RogueAV domains. So by linking all those events, which are in this case RogueAV domains, based on a number of features, but not always the same ones, we are able to unveil such complex patterns. So just to show you a close-up here, the zoom. So we found out that all the domains were an extension .cn, although none of the domains were actually or physically in China. So it's quite weird. Okay, so what did we learn? Thanks to the application of our triage framework, we learned, of course, that the user, but this is not new, but the user is the primary target. And in fact, what we found out in all those campaigns is that quite few RogueAV domains and quite few campaigns rely on drive-by downloads. This is quite amazing, in fact. So they prefer to pay because they make a lot of money. They can make much more money than what you and I can have even in 1 year. There are some figures that you can find on blogs, but usually they can, even an affiliate can make more money than you can earn in 1 year, just in a few weeks. So they prefer to pay to create those domains and to host them on ISPs that don't really look after the domain that they are trying to create. Then, so as I said, it's very different from the exploit website. Then what we found out is, of course, that blacklisting is strange, it's not useful, even not only IP, but also the domain base, because they have tools to create those domains in a bulk fashion. The only way to take down those rogue AV campaigns, in this case, we found out that it is through the payment processing side, or through techniques that are based on DNS. Okay, so just to conclude my first part, and then I will leave the stage to Andy. So triage is in fact one application of WOMBAT where we try to analyze the threats that we are observing through a multi-criteria decision-making scheme. So this is a new multi-criteria clustering and classification technique for the dataset that we collect. And the next step is, of course, to integrate triage with the WAPI and with Fire. And why is it useful? Well, of course, to get better insights into how the criminals in the cyberspace function, and how and when they change their tactics. And then it automates also the identification of networks of attackers. So it shows you which events might be linked to the same groups of people, of gangs. And then it can help us also to go towards an early warning system. Now, it is my pleasure to introduce you Andy, who is going to talk about Fire, which is another application of WOMBAT. And Andy, the floor is yours.
Thank you. Okay, so welcome everybody, also from my side. As Olivier already told you, in the second part of this talk, I want to introduce a system called Fire that we developed in the WOMBAT project. Fire stands for Finding Rogue Networks, and in this system, what we want to do is to attribute the attacks that we see on the internet to networks. Why do we want to do this? Well, we heard a couple of times already today that the structure of the threats in the internet is changing. So what we are seeing now is organized criminal gangs that have power, that have money, and they can afford their own networks, their own malicious networks that exist solely for the purpose of distributing malicious content. So what everybody knows are bulletproof hosting networks. They guarantee the availability of the hosted resources regardless of any content, and they host every kind of shady stuff that we know from the internet. I put a couple there, but you all know this. So what's the difference between a benign network and the so-called rogue network? Well, benign networks serve malicious content too. However, the difference is that rogue networks serve this malicious content persistently for a long time. If you complain at a legitimate network about some servers that host malicious content, then they usually take it down and remove the content. On the other hand, for example, the Russian business network's well-known bulletproof hoster was taken down some time ago for a short time. Attribo Indication, Macolo, the 3FN network. All those networks are examples for bulletproof hosters where malicious content can stay online for a very long extended period of time, in some instances even for years. So what we want to do is we want to defeat the root cause in the WOMBAT project. So basically we aim at taking down the rogue networks that we see. Why do we want to do this? If we can really take down a rogue network, this has a significant effect on malicious activities. I put you here the numbers for a drop in spam volume on the internet. When Attribo was taken down, the reduction was 20%, but when Macolo was taken down, for example, the spam volume dropped 75%. For a very short time, it was taken online later, but at least for a couple of months, the spam volume on the internet was reduced greatly, and that's what we want to achieve. Another thing that we can do, we can create efficient blacklists. So if we see a lot of malicious activity from one network, we can just say, okay, this is probably a rogue network, and we can block all the hosts on this network, even if you haven't seen malicious activity from certain hosts. So we can basically predict where malicious activity